Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening, Dr. Elena Hyde, and I'm joined tonight by Julie Tomei. We are broadcasting live from the Allan Carswell Observatory located at York University in Toronto, Ontario, Canada. Just as a reminder, this York Universe broadcast is in partnership with astronomy.fm. And even though we're not currently broadcasting directly from there, astronomy.fm is our partner for all of our shows. Now, just as a little reminder, this broadcast is also every Monday night. So if you're watching this live, it must be 9 p.m. or 9 to 10 p.m. local Toronto time, or Tuesday morning at about 2 a.m. UT. If you're catching this on a repeat and want to get the live show, make sure to tune in during that time slot. The York Universe production works in concert with our online public viewing program. That's right, that's what's running right now on YouTube, run by our observatory team at the exact same time as York Universe. If you'd like to get more details or find out about the shows or watch previous episodes, you can go to yorku.ca/science/observatory and follow the links to OPV, online public viewing, or Jane, any link that says YouTube from our website and go on over to OPV. Now, this is one of our many public outreach shows, and you can always connect with us on Twitter at York Observatory or York Universe, and Instagram, York U Observatory, and Facebook at Allan Carswell Obs to talk to our crew, find out more details, and just say hi. All of our programs are free, but if you'd like to make a donation, you can see that same website from before, /science/observatory at yorku.ca. Now, our crew is monitoring the chat rooms for questions, looking to post content, and right now in Toronto, we are actually having a little bit of a clear spot. It seems to be the skies are clearing, and we hope to be able to show you some beautiful live images from the 1 meter telescope later on tonight. So look forward to that over on our online public viewing. So if you're on YouTube right now, you're in the right spot. So Julie, how is it where you are?
The little bar at the bottom of my computer says that it's 20 degrees and clear where I am.
Yes, I was not expecting it to be quite this warm. Um, I have to admit, the last couple days we have seen it cool down a little, and we are back with a little bit of a heat wave, but it appears to be a slightly clear heat wave. So fingers crossed for lots of fabulous observing tonight.
Yeah, it has been record breaking for the first few days of October, last week of September. I'm not really complaining. This is the kind of weather that I love.
Yeah, around this temperature is pretty nice. It was a little, probably a bit too warm earlier this summer, but at least with this clear skies, we have the chances to observe some wonderful things. So we have a lot of wonderful objects out in the northern hemisphere sky to keep an eye on. The line of the planets is, of course, always a good one. So if you've got a clear horizon, you might actually see Jupiter coming up just above the moon.
Sure. And now that we're on the other side of the equinox, you don't have to wait quite as long to go out and observe.
Yeah, and that's always something to look forward to. Longer nights, hooray! Finally, the seasons are going my way again. But I suppose we should get our show on the road as well here. Speaking of things going, I guess.
Let's do it.
Let's do it. So we've got some This Week in Space and Astronomy History. So why don't you go ahead and start us off, Julie?
All right, we're going back over 100 years. Guess I'm not going to do the math because I will embarrass myself by forgetting to carry them on or something. But anyways, we're going to October 2nd, 1906, and the birth of Willy Ley. He was a German and American science writer and also a proponent of cryptozoology. We'll ignore that part. The science writer part, though, really cool. There's a crater called Ley on the far side of the moon that was named in his honor. He was born in Berlin, and his father was a traveling merchant, and he happened to be in Great Britain at the outbreak of the First World War, and so consequently spent the rest of the war in a detention camp in the Isle of Man. And his mother was working as a milliner in another city, so he stayed with two aunts during that time. He, quote, grew up, so to speak, in the shadow of the Museum of Natural History in Berlin, end quote, and as such had a great interest in science and exploration. He wound up studying astronomy, physics, zoology, and paleontology at the University of Berlin. You know, like you do, 4 majors, it's fine.
Yeah, that should be fine.
I think, you know, I guess at the turn of the last century, people were still studying a lot of things.
Well, I mean, to be fair, in 1906, the physics and astronomy manuals would have been a little thinner, so you would have that
Fair.
going for you at least.
And I guess, like, I mean, physics and astronomy is what I studied too, but and many of us on the team. But I did not attach zoology or paleontology to that. Wouldn't have found the time. He became interested in space flight after reading Hermann Orbach's book, Die Rakete zu den Planetenrahmen, and I apologize for butchering the German language. That translates to the rocket into interplanetary space. He was so enthralled by that book that he decided to write a popularization of this very technical work. He was 19 at the time. So he published this first book, Die Fahrt ins Weltall, Travel in Outer Space, in 1926. He became active in the amateur rocket community and wrote extensively for journals and newspapers, both in Germany and abroad. His and others' writing started a bit of a rocketry fad in Berlin, which led to exhibits and spectator events, excitement about both future possibilities of space travel and the potential for new, quote, weapons of wonder that could revive the German Empire. He was a consultant and advisor on Fritz Lang's 1929 film, Die Frau im Mond, The Woman in the Moon, which became the first realistic depiction of spaceflight in film history. The director, Fritz Lang, later recalled, quote, the work he had done as consultant and advisor was amazing. The models of the spaceship, really a highly advanced model of a rocket, and trajectories and the orbits of the modular capsule from the Earth, around the Earth and the moon and back were so accurate that in 1937, the Gestapo confiscated not only all models of the spaceship, but also all foreign prints of the picture, end quote. The German public lost interest in rocketry during the Great Depression. And meanwhile, rocket researchers were forming ties with the military. So Ley grew discouraged, but he continued to write articles. He left Germany in 1935, first headed to the UK and ultimately the US. He didn't like what he was seeing in Nazi Germany. He had established a reputation as an international scientist who openly shared and popularized technical information about rocketry, and his articles continued to be republished by foreign newspapers throughout 1934. So this likely would have made him a target eventually. In 1936, he supervised the operations of 2 rocket planes carrying mail at Green Lake in New York. He wrote science articles for numerous science fiction magazines. He also published some fiction under the pen name Robert Wiley. He joined the staff at a short-lived newspaper called The PM in 1940, where he met his wife. Some of his influential publications include his book, Rockets, The Future of Travel and Beyond Stratosphere in 1944, which described projects to reach the moon using a 3-stage rocket as high as 1/3 of the Empire State Building, which turned out to be a pretty good estimate of the height of the Saturn V rocket that was designed 20 years later. And his other book, rockets, missiles, and space travel from 1957 was cited in Space Handbook, Astronautics and its Applications, which was a staff report to the Select Committee of Astronautics and Space Exploration of the U.S. House of Representatives, which provided non-technical information about space flight to U.S. policymakers. He was a prolific writer, publishing a book a year, often two or more, and he died at the age of 62 on June 24th, 69, less than a month before the first Apollo moon landing. And at that time, he lived in Jackson Heights in Queens.
Wow, yeah, and what a combination of course, science and writing and multitasking all around, but also it is hugely influential what was going on at the time, because as you mentioned, he was the movie he got in trouble for was the 1929 film Woman in the Moon, but actually so that was German. There was another one from 1923, the Russian film, the Aelita Queen of Mars, which is, I totally recommend watching if you've got 113 minutes to kill. and don't mind a little bit of a slow burn. It's the depiction of space travel is not as accurate. Notably, like they would leave out a lot of like the details that would happen, in the rockets, how they would actually work for most of these early films. But it has some amazing sort of crazy like decoratively stylized sets that are really, really, really unique. And so you just don't, like, if you've ever wondered where certain aesthetics come from, I'm pretty sure it all like started back there. And so you get this great overlap with the amount of inspiration that early films were taking from science and from science fiction. And of course, the Germans had their Woman in the Moon. The Russians had the Aelita Queen of Mars, and there was many, many, many more. But of course, with World War I, you also had, a lot of politics all of a sudden very much involved with rockets and all that stuff. And then, of course, the moon landing and the space race and all that. It makes for kind of an amazing time in history, because it's just all of this was happening so close together. It sounds like it should be spaced out more, but no, it was all within the lifetime of this one guy, Willy Ley.
Yeah, it's fascinating. And I don't know, I've been, for work reasons, reading about German history at that time. So it's kind of like, oh, hey, all my different spheres are kind of like running into each other with this story, which is always interesting for me. And yeah, I mean, as much as I think we try to keep politics out of this show, they kind of seep their way into, science doesn't operate in a vacuum.
No, that's for light travel. The rest of us, so far we're all still here on Earth, pretty much.
Yeah.
But yeah, it is interesting how all of these things influence each other. And of course, him getting out of Germany when he did, obviously let him publish his later books on rocketry and be involved in those, later on journals and publications.
Yeah, he just wrote so much. I was looking at the list, the partial list on Wikipedia, because it says at the top, this is an incomplete list. Please help complete the list. It's so long.
Yeah, and for those of you who don't properly appreciate this, writing science articles is really hard. It is, getting a science article out is sometimes really a tremendous effort, and having somebody this prolific um, is very impressive. I can't imagine. But then again, lots of things in astronomy are hard to imagine. So I guess
That's
I
why
will. I
we
will just
like
take
it
a
so
quick,
much.
just a quick moment to let everybody know who is watching live. We do currently have a view of the Andromeda galaxy
Mhm.
on the live viewer. So if you would like to talk to our crew about the visible light from our nearest neighbor galaxy, spoiler alert, it's still very, very, very far away. That's actually up on the live stream right now, and all of the live images are actually live as of this air date. So it's not something pre-recorded. You're seeing what is in the sky in Toronto right now. So yeah, that kind of inspiration obviously was also very important to Willy Ley and to a lot of us working in science. Um, and getting these kinds of breakthroughs that allow us to get other places in astronomy and further our knowledge. Well, rocketry was such a huge, huge part of that. So that's how I'll get to my next item. So I have for my This Week in Space and Astronomy history, October 4th, 1957. So in the same regime. So speaking of, Russia and Germany and the space race, the spacecraft Sputnik, after the Russian word for fellow traveler, was launched at 10:29 p.m. Moscow time. Um, from a base in the Kazakh region. And this Sputnik was a pretty big deal because getting anything out of Earth's atmosphere has been one of the great challenges of humans. Earth's gravity is something that we were not easily able to overcome in the entire history. It's only very, very recently has it been possible to get anything up high enough to get it into even low Earth orbit. So Sputnik was the little spacecraft that could. It had a diameter of about 22 inches, nice and small, but it weighed in at 184 pounds and circled Earth once every hour and 36 minutes. So it was going at about 18,000 miles an hour in an elliptical orbit, and it had an apogee of about 584 miles, the perigee of 143 miles, and that is straight up in orbit around Earth. This launch was a tremendous achievement any way you look at it, but it was also very political, as we're saying. Russia and the U.S. being in a bit of a space and technology race at the time, and World War One and Two being fairly fresh for everyone. Um, so this satellite was actually visible with binoculars. So it was, just a few hundred miles up, and it was reflecting enough sunlight that just before sunrise or after sunset, you could actually see it just with binoculars. So you didn't need a giant telescope to spot it. And it transmitted radio signals back to Earth, which were strong enough to be picked up by amateur radio operators. So if you had a ham radio, um, you could actually tune in and listen. So in the US, a lot of amateurs, well, I'm not sure how many, but any with access to equipment could tune in and actually listen to the beeping Soviet spacecraft pass over America several times a day. So, if you had any doubt that it was happening, you could actually turn on your equipment and listen to it beep, beep, beep its way right past you. This was a big deal. So, we're talking about all this stuff happening around the same time. It was a tremendous amount of change, and this was really opening up the space race. So turning on Sputnik and getting it into orbit really opened up that whole regime. There wasn't anything else up there other than the moon before this. Maybe some things that exploded. But Sputnik actually successfully orbited Earth. And with the successful launch of the Sputnik 1 satellite, this was, as far as we know, the first human-made object to orbit the Earth. So getting out of Earth's gravity successfully, or at least enough to go into orbit. So this tiny little metallic sphere circled the globe for about 3 months and caused a huge amount of excitement. Like, it is very hard to overstate the incredible excitement this generated from absolutely everyone. It's hard not to be inspired by it, but even non-scientifically, it was amazing. There was actually something made by humans up in space. So it didn't have advanced controls. It didn't have the ability to really maneuver itself. So after a while, it did tend to deteriorate. So it was launched in October 4th, 1957, and by January of 1958, it had actually deteriorated its orbit and started to get a little bit too close to Earth, and at which point Earth's gravity wins again and the spacecraft burned up in the atmosphere. So it was officially launched to correspond with the International Geophysical Year, which is a kind of a fun solar period that the International Council of Scientific Unions had declared would be ideal for launching artificial satellites to study Earth and the solar system. But as we said before, it's hard to separate. You really can't separate the science from the people, and a lot of the people involved were a bit worried, but maybe this could bode for more sinister uses of rocket and satellite technology. And at the point, the Soviets' rocket and technology was actually much ahead of U.S. space rocketry efforts. So Sputnik was about 10 times the size of the first planned US satellite. So despite being quite small by today's standards, it was still 10 times larger than what the US was planning to send up, which wasn't actually scheduled to be launched until the next year. And the US government, military, and scientific community were both very excited and I guess very caught off guard by this amazing achievement. And basically this was really the start of the space race. So the US did manage to launch its satellite Explorer on January 31st, 1958. And by this time, the Soviets had already launched a dog into space, which is not maybe the best story, but they had actually launched a living creature into space aboard Sputnik 2. And they went on to find several other firsts in the late 1950s and early 1960s. The first man in space, Yuri Gagarin, the first woman, the first 3 men in space, the first spacewalk, and the first spacecraft to the moon, and the first to orbit the moon, the first to impact Venus, and the first craft to soft land on the moon. So all of those early victories did go to Russia, but of course the U.S. space race, struggling to catch up, actually managed to get a if you want to go, I want a great pun, a great step, or one big step ahead, when it actually, of course, that was the Apollo lunar landing, and I'll apologize now for the pun. So that was the Apollo space program, landing actual humans on the surface of the moon in July of 1969, which as Julie said, was unfortunately just after the death of Willy Ley, who had sort of caught a lot of this excitement, but just missed the human landing on the moon. Very, very interesting time all around.
I find it interesting that the Council of Scientific Unions is like, this is a great time to do a thing that no one's ever done before. Here's 12 months.
Yeah. Well, it's true on any cases. There's nothing like a deadline, I suppose, but also
Yes.
there's nothing like unified support. And someone asked me earlier, is like, would you ever be able to get enough scientists to lead a satellite exploration mission for Neptune or Uranus or one of the unexplored planets of our own solar system? It's like, oh, of course you could. If you,
Yeah.
if you could unite the funding behind them, oh my gosh, you could totally get the people to do it. And this was a really sweet spot moment where, of course, the politics, the funding, and the science aligned, and it really made a giant success for the U.S. space race to then sort of leapfrog ahead and actually land humans on the moon, which of course we're still talking about going back to, and we still haven't done. So, it's getting that unified human effort behind you is um, really amazing if it when it happens.
Yes. It's it, I'm sure all the scientists are just like, yes, chomping at the bit.
Oh yeah.
You just
Well,
have to get like the people with the pieces of paper
that's the thing is
organized.
it's something that we all do together, and that's kind of the nice thing about science, but it is what makes part of it really hard is if you don't have a really unified support, it's very, very hard to make that progress forward. So, uh, take that for what you will, scientific funding bodies.
Well, sure. I mean, this is why things like the International Space Station have been so important, right?
Oh,
To
absolutely.
have, like, I don't think any one country could have, well, I mean, I can
It's
think of a
the
few that if they
yeah.
reallocated military funds,
Yeah, but
maybe.
you're right.
But like,
It's the unified support, right?
yeah,
So we've reached a critical mass of support to make it happen, and with any less support than that, you couldn't do it. But once you have the support that you need to make the program work, it absolutely takes off and flourishes because the thing that you can always count on is your enthusiasts and your scientists will be right there to help you.
yes.
Um, and
Me, pick me.
exactly, no, it's like, oh, I will totally help you do that. It's, you want to go observe some binary stars? No problem. I will totally help you do that because I'm sort of an enthusiast. I love it. And I think, a lot of us are sort of the same way. Is it's you end up with some very, very good support, but you still need that community there for you.
Yeah.
And I suppose as you do for any mission, of course the one your next one is the Mercury. So I'll let you maybe talk about that, which also was a fairly interesting mission all in all.
Yeah. So I guess continuing with the space race, we're looking at October 3rd, 1962, and the launch of the Mercury Atlas 8, which was also known as Sigma 7. This was the fifth crewed US mission and part of the NASA Mercury program. And astronaut Walter M. Schirra Jr., I hope I pronounced his last name properly, orbited Earth 6 times in a period of 9 hours. The flight was mainly focused on technical evaluation rather than on scientific experimentation. And up until that point, that was the longest crewed mission that the US had pulled off, though, as we mentioned in our previous item, they were well behind the USSR, who had set a record of a several day flight earlier in 1962. The The mission did confirm that the Mercury spacecraft had the durability to move ahead with a one-day Mercury Atlas mission 9 that followed in 1963. The spacecraft orbited in both automated and passive flight modes for prolonged periods, while the pilot monitored it and carried out some minor scientific experiments. The capsule landed in the Pacific Ocean, a half-mile from the recovery carrier, and was hoisted aboard so Shara could disembark. Shara returned healthy after 9 hours of confinement in a low-gravity environment. But compared to previous Mercury Atlas missions, public and political reaction was muted because this happened around the time of the Cuban Missile Crisis, and so that was dominating the news. But the mission was a technical success. All the engineering objectives were completed without malfunctions, and the spacecraft used less fuel than expected. So, hurrah!
Yeah, and as you say, another one that obviously also took a huge amount of support to make happen, and definitely part of one of the many steps needed along the way to, a successful lunar program.
Oh yeah, absolutely. You can't just throw a tin can in space with some people in it without taking baby steps.
Yeah, well, you'd hope, that you do verify that humans will survive. So, I mean, they having them come back and verify it is okay. He was in low gravity. He seems fine. That's kind of important too. And having only minor problems is good. But it is also, as you mentioned, with the Cuban Missile Crisis, the unified support that you needed from the funding bodies and the government as well, takes sudden dips when other things sort of come to the fore.
Mm-hmm.
So their chance of losing funding actually went up when that happened because it lost priority.
Yeah.
But yeah, very, very interesting time, and an interesting mission in a period of lots of interesting missions.
Yeah. Yeah. It's interesting that a more different rocket got in the way of this rocketry.
Yeah. Well, and the rocket technology as well was really interesting because a lot of this was done, or developed, I should say, not done, but developed in a very seat of the pants kind of way. And they had these testing ranges out in the Nevada desert in the US, and I believe some parts of California as well. And they were running just hugely unsafe tests. And everybody from amateurs to professionals were out there trying out new rocket nozzles and parachutes and crazy things and being way too close to them when they went off. And so, there was this very, I mean, I know it said probably a little bit too much, but there's a very sort of cowboy kind of exploration to a lot of this. But it was fast development, and a lot of absolutely genius people were involved. And again, community, bouncing ideas off of each other, sharing thoughts, sharing designs, sharing schematics, and that kind of supportive, I mean, perhaps a little bit crazy, scientific community. Literally exploding things and developing things. You see rockets change a lot in design, in shape, in composition, from the earliest rockets out through. Well, I mean, even now we're seeing amazing changes with, of course, the spaceship rocket versus, some of the old, now I'm going to get some of the old Atlas rockets, for example. Anyways, rockets are awesome.
Yes. Very cool.
But so is other technology. And we talked about some of the things that were developed throughout. And I think for my next item, I'm going to go back in history a bit, because we were talking about the development with physics and astronomy and rocketry in the early 1900s with Willy Ley. But also there was something else going on in the early 1900s, and that was um, a very strange new discovery that we had never seen before as human creatures, to our knowledge. Like there's no artifacts that show we ever developed this in history before. And this was a certain kind of signal that could be transmitted easily in Earth's atmosphere, and this was radio. And if we go back to this incredible time period, which was put in sort of Willy Ley's lifetime, I guess, is how I'll refer to it, sort of the 1906 through 1969. In the early 1900s, this was not very common. So I have to go back a little bit before the 1900s. In 1888, there was a book called Looking Backwards. And this imagines, in an 1888 novel, a traveler from 1887 reacts to a technological advance in the 21st century. And this is described as an arrangement for providing everyone with music in their homes, perfect in quality, unlimited in quantity, suited to every mood, and beginning and ceasing at will. So the author's imagination, Edward Bellamy, this astonishing feat, this is amazing, never before heard feat of almost magic. This could be accomplished by a vast network of wires connecting individual homes with centrally located concert halls staffed round the clock with live performers. So this vision was of the year 2000. And this was way, way sooner than the author thought. So this was 1888, and on October 1st, 1920. So our reference human, I suppose, of Willy Ley, he would have been 14, I guess. So he was born in 1906. So in 1920, on October 1st, the Scientific American magazine reported that the rapidly developing medium of radio would soon be used to broadcast music. And I thought, well, what better item for a astronomy radio show than the development of radio? So this isn't just about music, obviously. This was a revolution in the role of music for everyday life. The idea that you could just have music in your house, like you would have had to have a literal human in your house who could play music if you wanted this before. So how good of music you got in your with your dinner would entirely depend on how good you were at playing an instrument. But now anyone could have all kinds of music just every day. It's amazing. So it was known by 1920 that by placing a form of telephone transmitter in a concert hall or any point where music is being played, the sound could be carried over telephone wires to a telephone receiver at a distant point. So this was in the October 1st, 1920 issue. But at the time, they said, and this is a quote, "It is only recently that a method of transmitting music by radio has been found possible." So after the World War I practical technology sort of explosion, by late 1919, experiments had already started in Britain and the United States and elsewhere that would lead to sort of a breakthrough all over at once of radio, not just as a replacement for telegraph, but also as a communications network and a way to entertain, or an entertainment medium. So a lot of these experiments were taking place in the National Bureau of Standards in Washington, D.C. in the U.S. And this is where station WWV was established. So they set up a station to test various means of radio transmission. So they were relying on amateur radio operators in the local area. So they, again, picking out those enthusiastic scientists and saying, all right, give us feedback on our experiments and we'll start trying to send out broadcasts. And they started testing the transmission of music in 1919 and early 1920. And that, of course, led to the public announcement in the Scientific American that music can now be performed at any place, radiated into the air through an ordinary radio transmitting set and received at any other place, even though hundreds of miles away. And then the report states, so their official quote is, quote, the music received can be made as loud as desirable by suitable operation of the receiving apparatus. So this means you get a volume button as well. So you could have all kinds of things happening, obviously. And this is from the same article. Experimental concerts are at present being conducted every Friday evening from 8:30 to 11 by Radio Laboratory of the Bureau of Standards. The possibilities of such centralized radio concerts are great and extremely interesting. So this is all happening in the early 1900s, so 1920s. And of course, early radio shows really took off. And of course, radio was an amazing source of entertainment. And, being our own York Universe radio show, it's still useful. And around the same time, we had radio, so it's not just being used for, for military purposes anymore. Radio starts taking off and people start using it. So that's 1920. In 1932, so just a few years later, we had the first real radio source identified from astronomy. And so radio comes into astronomy in a big way. 1932, that was when American physicist and radio engineer Carl Jansky detected radio waves coming from an unknown source in the center of the Milky Way galaxy. So Jansky was studying the origins of the radio frequency interference for Bell Laboratories, and he found a steady hiss of static of unknown origin. And he concluded it must be extraterrestrial, and he was absolutely right. And that was the first radio waves from outer space. So you can imagine how much interest and press this got, because of course people had learned they could transmit music through radio, and then all of a sudden there were radio waves from outer space. It sounds like a sci-fi title, but it really happened. And of course, the first radio sky survey happened in 1941. And by the 1970s, we had some stars, individual stars, which were known to be radio emitters. And radio astronomy is still one of, well, it's a major component of astronomy and giving us now a really gigantic big data analysis problem, because there's so much data coming back from radio telescopes. So radio and astronomy and the 1920s, again, so much was changing, and we saw so many major breakthroughs in how we understood not just astronomy, but also the technology that we had. And using radio for communication was one thing, but then detecting it from space was kind of like, wow, this, and that was all again, before, mostly before 1960, 1967. So, and they say interesting times, they're not lying.
Yeah, very cool. So cool that the guy in 1888 was like, here's the thing I imagined.
Yeah, well, he's imagining it for the year 2000. And he's like, in the year 2000, I think by the year 2000, people have music, like anyone can just have music in their house. And it's like, oh, how about like in 12 years? Because
Okay, I'm gonna.
By 19, it's like, wow, that's amazing. So it happened even sooner even sooner than he would have thought. And when they say even stranger than fiction, this is what they mean, because it was, of course, just a fantastically interesting time all around.
I was like so curious. I was like, was he still alive when it happened? But he wasn't.
Oh, the author? No, I
Yeah,
don't think so.
no, he died in 1898.
Yeah, he was, I think he was fairly old when he published the book.
Yes.
But yeah, unfortunately, he did not get to see his success. But um, um, but he still did have it, and it's still, like, I recommend the book if anyone is interested in historical novels. It's very it's got a lot of interesting ideas. All right, so I think it's a little past halfway, so it's about time that I remind everyone that you are in fact listening to York Universe. We are broadcasting live. And tonight we are truly live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. And of course, if you have any questions or you'd like to find out more about our programs, you can always see our website at yorku.ca/science/observatory. And you can find us on Twitter at York Universe, at York U Observatory, and Facebook and Instagram as well. Tonight, you're listening to Dr. Elena Hyde and Julie Tomei, and you are how far did we get through history? I believe we're discussing, I guess, major breakthroughs of the sort of early 1900s, really,
Yeah.
and some fun launches as well.
Mm.
So we've got all kinds of great stuff for you tonight, and there are actual live images currently on screen over on our YouTube channel. So if you're following along, you'll be able to see, I believe, Alberio, which is a lovely, lovely binary star system.
I think they moved to Altair.
Oh, Altair now. Is it Altair?
Yeah.
Well, Alberio and Altair are both very good. So I suppose if you missed Alberio, go back a little bit.
Yes. And go back a little bit further because Saturn was
Yes. Well, this is why it's always nice to get them recorded.
Yes.
So we have lots of wonderful current real-time viewing happening, courtesy of the Malin Cam on the 1 meter telescope at the observatory, and double courtesy of it not actually being too cloudy. So, hooray for that! Now we do have a couple little reminders. I suppose first reminder is that we are back with in-person viewing on Wednesday nights. So if you are wanting to come along to this Wednesday's public viewing, make sure to sign up on the website and get Eventbrite tickets. It's the same website I've been giving everyone all night, yorku.ca/science/observatory. And there's also another fun reminder. We've been talking about Bennu a lot, and I see, Julie, you've put in the NASA broadcast.
Yes. So on October 11th at 11 a.m. Eastern Time, NASA will be broadcasting that final step of getting the sample out of the sample head.
Wow, you've got to have steady hands. Just nerves of steel to do that. Yeah, it's been extremely exciting. And of course, if you missed it before, make sure to go back and watch the recap live stream of the sample coming in to the desert from Bennu, because they had the whole capsule trajectory, and they showed where they thought it landed, and then they had all the people standing nearby to run into helicopters and chase it down so they could pick it up. It was, and it still is super, super exciting. And of course, Canada, we get to keep some of this once it's been processed, and so sometime next year, we're going to be getting a few 4%, which will be a couple grams, if it really is 250 grams. So I don't think they've released how many grams it actually is.
Yeah, I don't know that they have.
Well,
They may not have that yet because
if it really is 250, we should be getting about 10 grams.
Yeah.
So fingers crossed for that. And I say we, like Julie and I, we're going to be getting it, but it's not us. It's they're going to be sorting.
It's not me. It's just my place of employment.
Yeah.
Yeah.
So
Some
don't ask us if you can look at it, but
no, I will not have access to that.
No.
For sure.
If we're lucky, we'll get pictures though, and those we can share.
Yeah.
And it is really, really exciting for so many reasons, and origins of the solar system, but also just understanding more about this asteroid, and this is the first one, so maybe we'll be able to do more now. Yay! Very
more
exciting.
Science, more space.
Yeah, and well, if we get enough people interested and we can build a big enough momentum behind this, we could bring more samples back and uncover more mysteries, which is just science all over. So speaking of mysteries, I suppose we should get to the news item before it gets too late today.
Yes.
Julie, so James Webb Space Telescope is still amazing and
will always be amazing
and has yet another amazing discovery. So tell us about the supernova.
Okay, so there's a type 1a supernova called SNH0PE, which I will from now on be calling supernova Hope. I don't know if that's how everyone else refers to it, but that's how it's been happening in my brain. And it was first discovered in JWST images in March, and it is gravitationally lensed. So it actually shows up 3 times in the images. And in these images, the exploding star can be seen as an arc of orange light with 3 bright points that surround part of a galaxy cluster called PLCKG 165.7 plus 67.0, or just G165, because we are really good at naming things. I've said it before and I'll say it again. Anyways, this galaxy cluster is about 4.5 billion light years from Earth. In case you need a reminding, gravitational lensing is an effect caused when light from distant objects pass through space-time that has been warped by gravity from a massive foreground object that is positioned directly between the distant object and the observer. So it warps the image of the object, but it also magnifies it, and so can make it easier to analyze. So the supernova is 16 billion light years away. And this object and others like it that may be found in future JWST data could help solve a long-standing inconsistency about the expansion of the universe, the quote, Hubble tension. The Hubble tension, dun, dun, dun.
Yes, it deserves a nod.
It kind of does. The Hubble tension is caused by the 2 main ways of estimating the rate of expansion of the universe not agreeing with each other. So in one method, we look at the cosmic microwave background, and the second method involves measuring distances to specific objects like galaxies and supernovae. And the distance measuring method is consistently giving slightly higher value than the CMB method. So the question is, which is right? So supernova Hope, being a type 1 supernova, is a standard candle, so a reliable reference point for distance measurements. So type 1a supernovas are white dwarf stars that steal matter from its binary partner. It reaches critical mass and explodes. And the brightness, it's a bright explosion that has near equal initial luminosity and dim over time at the same rate. So we know if you see one of these, you can say, oh, it appears this bright, so it's at this distance. So comparing these standard candles at various distances from Earth, scientists can work out how fast they're moving away from us and can deduce the rate of expansion of the universe. Supernova Hope is the second most distant type 1A supernova detected so far, and the gravitational lensing gives astronomers some more data to work with than usual. This is a new data point to solving this mystery, adding to work published earlier this year in which scientists used data from a reappearing quadruple lens supernova named Refsdal to calculate a new value for the Hubble constant. And it's still different from the one calculated using the cosmic microwave background, but the distance between the two is smaller. So maybe if we find enough of these, we could refine that calculation, they can match up. So it's unclear if this new supernova, Hope, can be used to calculate an even more reliable value, but scientists are hopeful, and JWST is very likely to find even more of these important standard candles. Huzzah!
Amazing. And of course, the answer to all of our questions can be solved if we just have more data. It's the eternal astronomy problem. But getting slowly closer to a consensus is great, because the more different methods you have that agree, the more your overall error bars go down, and you can be somewhat more sure of what's actually going on, because it's important to remember that at these distances, it is very hard to say anything with certainty because it is so far out of our galaxy.
One of the things I remember, you go to university for 4 or 5 years in my case, and you spend a lot of time in class, and some of the things you remember and many of the things you forget. But one thing I remember is Professor McCall saying, distance is the Darth Vader of astronomy.
Yeah, it really is. It's just it's very, very hard to really get your head around the incredible distances out there, especially when you get to galaxies, but even just in our own solar system.
Measuring distances to things, right? Like astronomers got to be so creative.
Yeah, exactly. And finding these objects and pinning them down. And, of course, if it's another galaxy, you have to worry about the intergalactic medium and any dust in the way, and what else might be going on. There's just so many possible explanations for why your measurement might be wrong. Anything you can do to beat down your errors is going to be good. So I hope they get many more observations and are able to average them down and come up with a somewhat of a consensus with the CMB.
Same here.
All right. So once again, we only have a couple minutes for our last little news blurb, because we're just too good at talking about astronomy. So I'll tell everyone about this, and we'll probably discuss it again on this show at some point. But I did want to mention that there is a very fun article which has just come out from York University. So from our own university, and one of our own professor recently emeritus. This is, does antimatter fall up or down? And the specific question is, would an antimatter apple fall up or down? So if you had a normal apple falling from a tree, it would hit the ground on Earth. But if you had an antimatter apple, what would it do? So this was a question that was answered by York University Professor Emeritus Scott Maneri and his recent paper. So if you want to read out more of this, make sure to go to yorku.ca/news for this month and just search for antimatter apple and it'll pop up. But basically, they didn't actually create an entire apple of antimatter because that would take a lot of antimatter. But this tests Einstein's theory of general relativity, which basically says that what must be true for matter is true for antimatter. So is general relativity going to hold for antimatter? And in this case, would it specifically hold for antihydrogen? So antihydrogen is like hydrogen, but made of antimatter. Sounds simple. All you have to do is create antihydrogen, trap it so that it can't react with anything, and then, of course, observe its behavior. So
Sounds simple
creating an
enough.
antimatter trap can be done all kinds of different ways. There's actually some really cool photonic crystals that I saw designs of years ago, but we don't have time to talk about those. But antihydrogen, like hydrogen, falls down, not up. So antihydrogen experiences gravity in the same way that hydrogen does. So gravity is a much weaker force than most people really think about, because it's the whole Earth, but it takes the whole Earth to make the gravity that we have so much trouble escaping. So the gravity of your fellow humans is not going to affect you at all. So finding gravity's effect on something as small as a hydrogen or an antihydrogen particle, basically you have to put up some very, very, very fancy machines. So they built an entire apparatus at CERN, and basically it was a lovely little anti-hydrogen trap. And you hold them then in a cold magnetic bottle. So you create a strong magnetic field, and basically you can hold it, keep it from interacting with anything, but also allow it to respond to gravity. And sure enough, it went into free fall, and yeah, it responds to gravity in the same way that you would expect. And they're working on upgrading their apparatus using laser cooling to get a more precise measurement. But so far, they have a solid measurement showing the antihydrogen does actually fall down. So even if you had even if you had anti particle boots, they still wouldn't be anti-gravity. So once again, gravity wins. I'm sorry, antimatter is not going to give you the solution to anti-gravity. So some sci-fi movies owe me a refund, I suppose. But it's a very, very fun little news article, and we'll probably talk about it more on this show, like I say. Little something extra from our very own York University.
Awesome.
All right, everyone, that is all we have time for tonight. You have been listening to York Universe, the astronomy and astrophysics program written and presented by students, faculty, alumni, and friends of York University. The hosts this evening have been Julie Tomei and myself, Dr. Elena Hyde. As a reminder, for all of our show contents and updates and all of our contact information, you can always go to yorku.ca/science/observatory. Thanks for tuning in to York Universe. Clear skies and have a good night.
Good night.